Hi, welcome to the Olympiad geometry. Let's continue our study on geometry treasure. Today we are going to talk about the Desargues theorems and Converse. Basically, this can be considered as an extension of the Menelaus theorem. Well, it's used the Menelaus theorem, but let's say, given two triangles, if the lines joining the three pairs of corresponding vertices are concurrent at a point, and if the corresponding sides intersect in 3 points, then these 3 points are collinear. The converse statement also holds. So basically, it's saying like this. We can find one triangle, and we can find the second triangle, right? First triangle and the second triangle. That's a given two triangle. And if the lines joining the three pairs of corresponding vertices, which are these lines, these three lines, right? These three lines are concurrent on this point. And if the corresponding sides intersect in 3 points, so this one and this one intersect on this point, this line and this line intersects on this point, right? And this one and this one intersect on this point. Then the 3 points are collinear, right? These 3 points are collinear. So let me give we mark this is F, okay. We mark the vertices, and let's consider this one as X. Okay, basically we are saying that triangle ABC and triangle DEF, they have the corresponding pairs connect together, and then 3 lines are concurrent on point X, and corresponding sides intersect on 3 points. Let's call it P, Q, and R. Then we want to prove that P, Q, R are collinear. Okay, so for this kind of problem, I think we practiced before. Because we have so many lines here, right? That means we can use the Menelaus theorem a lot and multiply them together and then use the converse of the Menelaus theorem to prove that 3 points are collinear. So for here, I'll just write it. Look at the triangle XAB, right? Triangle XAB. Because if we want to use the Menelaus theorem, we want to find a triangle and find the PQR as a line that intersect with this triangle, right? So here we find the triangle ABC and we find PQR as an intersection line, which means that we want to find the segment ratio of AP, BP, BQ, CQ, CR, AR, right? But these are not in one already known triangle and intersection line, right? So we have to find like several triangle and intersection lines. The first one would be XAB, and the line PDE, right? And the second one would be XBC and the line So you can see XBC and the line QFE. The third one would be the triangle XAC. Right? So that's a line DFR. Okay, for the first case, we have XD to AD, right? XD to AD times PDE, right? Triangle XAB. So XD to AD times AP to BP times BE to XE equals to 1. And for the second one, we have, because we want to have this XE to BE cancels, right? So we use XE first. XE to BE. XE to BE times BQ to CQ times CF to XF equals to 1. Right, that's the second. And for the third, the triangle XAC, for the triangle XAC, we have CF to XF, right? So we want to cancel that, which means we use XF first. So XF to CF, XF to CF times CR to AR times AD to XD equals to 1. And then we multiply these three equations. We know that BE to XE cancel with XE to BE. CF to XF cancel with XF to CF. AD to XD cancel with XD to AD. Which means AP to BP times BQ to CQ times CR to RA, right, equals to 1. That's exactly the Menelaus theorem using for the triangle ABC and line PQR, which means that we use the converse of the Menelaus theorem. We can say that P, Q, R are collinear. Right, that's for the Desargues theorem. And for the converse case, right, for the converse case means that we can assume that we have the triangle ABC and the triangle DEF here, right? And we have these three intersection points as P, Q, and R, and we force them to be collinear, right? We know these 3 points are collinear. P, Q, R are collinear. Now we want to prove that AD, BE, and CF are concurrent. We want to prove this, right? So we assume that AD and BE meet on point O, and B and CF meets on another point O prime. Actually, let's still use X, okay? X and X prime. Right? So we can still use a meaningless theorem which for the triangle XAB and the line PDE, we have XD to AD times AP to BP times BE to XE equals to 1, right? And for the triangle X prime BC and the line QFE, right? We have X prime E to BE times, right? For the triangle X prime BC and the line QFE. So we have X prime E to BE times BQ to CQ times CF to X prime F equals to 1. Right, we have these two. And also we have triangle ABC and the line PQR, which is, let's think about that. I want these things to be cancelled. Right here is AP to BP. So let's still use that, which means we have AP to BP. Oh, actually we use BP to AP, so it's easier to think of. So BP to AP times BP to AP times AR to CR times CQ to BQ equals to 1. Right? Then we multiply these three. Right? So we have AP to BP cancel with BP to AP. And we have CQ to BQ cancel with BQ to CQ. Right? So what we left is XD to AD times XD to AD times, I'll write this first, AR to CR times and C, so we have CF to X prime F times X prime E to BE times BE to XE equals to 1, right? So B and BE cancel. So we have XD to AD times AR to CR times CF to X prime F times X prime E to XE equals to 1. Right, that's what we have. Now we can assume, we actually already assume that X prime and X are different points. Which means X prime E to XE does not equal to 1, right? So if we look at the figure, let's go through this production. We have XD to AD times AR to CR times CF to X prime F times X prime E to XE equals to 1. If this is true, and we know that X prime E doesn't equal to XE, we can only get the conclusion that P, E, Q, R are collinear. Why? This is based on our previous video, that's the generalization for the meaningless theorem in the polyline, right? We derived that. which is obviously not true because E is not on the line PQR, which means our assumption is invalid, which means x prime E equals to xe. And we can again verify it. If x prime equals to xe, then we get xd to ad times ar to cr times cf to xf equals to 1. Right? Which means, see here, xd to ad times ar to cr times cf to xf equals to 1. Right? And we already in the assumption that x prime e equals to xe, and the inconsistency, which means it's true, which means that AD, BE, CF are concurrent. Right? So for the Desargues theorem, I would consider it as a more generalized way or expansion way of the meaningless theorem, but this is an extremely important theorem in the projection when we learn in the future for the projections. Okay, I hope you like this video, and if you think this video is helpful, please click the like button, comment, share, and subscribe to the channel. Okay, thank you. See you in next one.